Okay, today we're going to learn about two other ways to prove that triangles are congruent by using the angle side angle and angle angle side, or we can call it the side angle angle congruence shortcuts. The first one is the angle side angle congruence postulate, and that says if you have two angles and the included side, remember included means in between, included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So here we have two angles in one triangle congruent to two angles in another, and the included, meaning the side in between the two angles, are congruent. Then these two triangles are automatically congruent by the angle side angle congruence postulate. And our congruency statement for this one would be triangle A, which matches up with D, triangle B, which matches up with E, and C, which matches up with F. The next shortcut is the angle-angle side congruence theorem, or you can write SAA for side angle angle, it doesn't matter. And that just says if you have two angles and a non-included side, that means a side not in between two angles. So if two angles and a non-included side are congruent to two angles and a non-included side of a second triangle, then the triangles are congruent. So two angles in one triangle congruent to two angles in the other, and then non-included side. If it were included, it would be in between these two angles, but it's not included in between the two angles. Okay, so number one, first look to see if there's anything we can mark on our picture. And we don't have any shared sides, we don't have any angle bisectors or anything like that. So we're going to name the postulate or theorem that we can use to prove the triangles are congruent, and then write a congruent statement if they are in fact congruent. So here we have an angle, an included side, and an angle, congruent to an angle, an included side, and an angle. So we do have an angle side angle postulate, and then our congruency statement. U has 1, 2, 3 arcs, so that matches up with X. V has 1, 2 arcs, so that matches up with Y. And T has no arcs, so that matches up with W. Alright, number 2. The first thing we can mark on this picture is vertical angles. Vertical angles are congruent, and we have to put 3 arcs on here because 1 and 2 arcs are already taken. And there's nothing else we can really mark here. We don't have any shared sides, and we don't have anything written to tell us to mark anything. So we don't have congruent triangles. So we don't have a congruency statement, and the reason is they're not congruent. Alright, I want you to try number 3. Pause the video and see if you get what I get. Alright, you should have gotten triangle MLP in exactly that order of the letters. And your reason is angle angle side or side angle angle. You have an angle, and a non-included side. An angle, and a non-included side. And that is one of our postulates to prove that two triangles are congruent. Okay, number 4. The first thing that you can mark in number 4 is your shared side. You always mark your shared side because HJ is congruent to HJ. And we can see here that we have an angle, an included side, and an angle congruent to an angle, an included side, and another angle. So we know our reason here is angle side angle. And if we match up our angles, we can see that HIJ, H has 1 arc, so it's going to match up with J in the other triangle that has 1 arc. I has nothing, so it's going to match up with K that has nothing marked. And J has 1, 2 arcs, and that's going to match up with H that has 1, 2 arcs. Alright, go ahead and try number 5 and 6 on your own and see if you get what I get. Go ahead and pause the video. Okay, you should have exactly the same order of letters that I have on number 5 and number 6. And if you put angle angle side versus side angle angle, either one of these is correct. It just depends on how you write it. And you should have had angle side angle for number 6. All right, number 5, the first thing that you should mark is that shared side. So if you see, we have an angle, and a non-included side congruent to an angle, and a non-included side. And when we're making our congruency statement, J has one arc, so that matches with L. U has 2 arcs, so that matches with the other U. And K has nothing here, so that matches with the other K. Number 6, the first thing that we should mark here is our vertical angles. We always mark vertical angles. And if you look at this first triangle ABC, we have angle, included side, and angle, congruent to angle, included side, and angle. And the letters, B has nothing marked, so it matches up with E. A has one arc, so it matches up with D. And C is the vertical angle to C, so it matches up with C. Okay, for 7 through 9, we're going to mark the third congruence that must be given to prove that triangle ABC is congruent to DEF by the indicated postulate or theorem. And then we're going to write which segments or angles we mark congruent. So here, if we want it to be an angle side angle postulate, we have an angle and a side in both triangles. So we need it to be another angle marked. So we have an angle and a side. We need another angle marked in order to ensure that the side that's marked is in between the two angles. So if we mark F, then we have angle, included side, angle. Congruent to C, then we have angle, included side, and angle. So we would have to mark angle F congruent to angle C. All right, go ahead and try number 8 and 9 on your own. Pause the video and see if you get what I get. Okay, for number 8, you should have gotten that you marked C congruent to E. In order for this to read angle, angle, side, you have to mark the non-included. You have to make sure the side is not included. So if I put an angle here, it's angle, angle, side. If I were to put it here, it would be angle, side, angle. So we have to put it at C. And the same thing here, angle, angle, side. If I were to put it here, I would have gotten angle, side, angle, because then the side would have been included in between the two angles. And number 9, it had to be side, angle, side. So the angle had to be included. We already had 2 sides marked. If I put the angle here, it would not be in between the 2 sides. It would be side, angle, nothing, side. We don't have that. So it had to be at angle A. And it also had to be at angle D. In between the 2 sides was angle D. Okay, and there are only 2 reasons that we absolutely cannot use to prove triangles are congruent. The first one is angle, angle, angle. These 2 triangles, ABC and EDF, all have 60 degrees congruent angles, but clearly one is bigger than the other. So these are absolutely not congruent. And the same thing here. You have a 50, 40, 90 triangle, a 50, 40, 90 triangle, and clearly HGJ is bigger than EDF. So angle size doesn't determine congruent triangles. The second one is side, side, angle. Here's an example of a side, and an angle. Side, side, angle. The sides are congruent, the angle is congruent, but clearly this triangle has a smaller shape altogether than this triangle. Here's another example. Side, side, angle, side, side, angle, where this side and this angle are congruent, but the triangles are clearly not congruent triangles. So we never want to use this or this as a reason. All right, and the last thing we want to do is talk about the theorems and postulates using our definitions for vocabulary. So we want to look at the vocabulary that's given. It says, well, first of all, for letter A, let's look at what we can mark before we read the vocab. We automatically should see that side BD is a shared side. So BD is congruent to BD. Then let's read what it says. It says BD is also an altitude of triangle ABC. Well, an altitude, remember, if BD is the altitude, then an altitude connects a vertex to an opposite side at a right angle. So we should also mark that these two angles are right angles. And the next thing says that BD is the angle bisector of ABC. Well, here's ABC, and it says that BD bisects angle ABC. So here we mark our congruent cut in half angles. So now if you see, we have an angle, an included side, and an angle in one triangle congruent to an angle, an included side, and an angle in another triangle. So we definitely know this is angle side angle. And making our congruency statement. A has nothing marked, so it must match with C, which also has nothing marked. B has 2 arcs, so it must match with B that also has 2 arcs. And D is where our right angle is, so it must match where our other right angle is. Alright, I want you to pause the video and see if you could try the next two on your own. Okay, you make sure that you have the letters in the exact order that I do. So it must be JMK and RQS, and your reason for both of them is angle side angle. Okay, the first thing I'm going to do is mark my shared side, KM. And I'll go ahead and mark it here on the other picture, QS. Then it says angle LMK, L to M to K is this angle here, is congruent, so I'll put my arc, to angle JMK. J to M to K is here, so I'll make my arc here. Then it says that KM, this segment KM, bisects LKJ. So here's LKJ, and this LKJ has been bisected. So if you see, we have angle and included side angle, and angle and included side angle in both triangles. Alright, I guess the last example. First thing I marked was my shared side. Then it says that QS bisects PQR. P to Q to R, this angle has been bisected. So I'm going to mark this angle congruent to this angle. And then it says PSQ, this angle, PSQ, is congruent to RSQ, this angle here. So we have an angle side angle congruent to an angle side angle, and that gives us angle side angle. And then our congruency statement, P has nothing, that matches with R. Q has 2 arcs, so that matches with Q in the other triangle, it has 2 arcs. And S has 1 arc, so that matches with the triangle in the QSR that has 1 arc as well.